Okay, so we've been doing confidence intervals and hypothesis test, but the one thing we really haven't talked about is the chance that we might make an error. And so this chapter is about the type of errors that you can make and what you can do to try to prevent them. And so we're going to start out by talking about the first type of error, which we will call a type 1 error. A type 1 error is if you reject the null hypothesis. So we take our data, we find the z-score, we get a very small p-value. So it looks like our data is significant. So you're stating that there's evidence for the alternative hypothesis. With a very low p-value, we're going to reject the null. We have evidence that the alternative is true. When in reality, we shouldn't have rejected it all. That's a type 1 error. So saying that a new product is going to work because it's better than the old, when in reality is not better than the old. It just, by happen chance, remember, we can get our data a certain percentage by chance. That's what p-value is. Well, we hit that, we'd end up hitting that small chance that we said it was significant when really it's not. And if that happens, it's a type 1 error. So it's rejecting the null hypothesis, or in other words, stating there's evidence for the alternative hypothesis, when in reality, we shouldn't have rejected the null to begin with. The probability that you'll make a type 1 error is the alpha level that we choose. Now, our rule of thumb has always been alpha 0.05. You can make any alpha level you want. You can make alpha level 0.10. And if the chance of you getting a result is less than 10%, you would say, hey, we reject, we have evidence for the alternative. You can make an alpha level very small, like 0.01. So in other words, you have to have results so far out, so far away, it could happen less than 1% of the time. And if that happens, then you would reject the null. And so the chance or probability you'll make a type 1 is purely your alpha level. If you want to reduce the probability of a type 1 error, reduce your alpha level. So if alpha level is 0.05, that's a 5% chance at a type 1 error. If alpha level is 0.01, that's a 1% chance at a type 1 error. We will look at the errors more in context when you come into class, but right now I just want to get down the basics. The other type of error we talk about is a type 2 error, which is kind of like the opposite of a type 1. It's failing to reject the null. In other words, stating, oh, our data is not significant enough. We're only a little bit away from what we think it should be. When in reality, we should be rejecting it, okay? We should be rejecting it. So we don't find enough evidence that this new process is any different than the old, when in reality it really is, and it should be rejected. That's a type 2 error. Now, here's where it gets a little tricky. The probability of making a type 2 error is called beta, and beta is a number that we do not have yet. Nor will we calculate it. We don't have to calculate it in this course. You just have to know that it's beta. And we're going to put that aside for right now. The power of the test is doing what it is that it's supposed to do. It's rejecting the null when it should be rejected. You have evidence for the alternative when you should be. That's not an error. It's called power. Power of the test. And the thing is power, the probability that you make power, that you have power, is 1 minus the probability of beta, or making a type 2 error. So power plus type 2 error will always equal 1. So if you know power, 1 minus will give you the chance of a type 2 error. If you know type 2 error, 1 minus that number will give you the probability that you have the power of the test. And the last piece, if you want to reduce the probability of a type 1 error or a type 2 error, in other words, I want to have less opportunity for error. Think about, what could we really do? We can increase the sample size. Think about it. If we talk to more people or survey more things, our law of large numbers says it should get more and more accurate, closer and closer to what it should be. All right? This will also increase power. Again, your result should come out to be maybe what it's supposed to be now. So, reducing errors, increasing power, increase sample size. Now, if I do increase my alpha level, my level at which I'm willing to reject at, notice type 1 will increase, but type 2 will decrease. So let's say my alpha level is 0.05. And I say, let me make it bigger, let me make it 10%. So now the chance that I reject when I shouldn't be goes up. But type 2, the chance that I fail to reject now went down because I might reject now when I shouldn't have. And because type 2 goes down, power goes up. And that's it for errors. We're gonna have some real life scenarios in class and some problems to look at. But basically, again, to recap, type 1, hey, this new product's working, when really it's not. Type 2, that new product doesn't work at all, when really it does. Power, that new product works, and it really does work. Power is doing what we think it should be doing. Okay? And again, reduce errors, increase power by increasing sample size. But if I do increase my alpha, type 1 goes up, type 2 goes down, power goes up. And that's it.